Welcome, everyone. Kevin Carpenter, volunteer at CppCon. Happy to be coming to you, interviewing with Fedor Pikus, which did I say that last name right?
Because
Pikus. I apologize. So I got the pleasure of seeing Fedor's talk at C++ Now, and when I found out he was doing an academy class, I was even more excited. And as well, it's my first time getting to interview with you. So, Fedor, why don't you tell us a bit about yourself?
I I'm currently a technical fellow at Siemens Digital Industries. Came from Mentor Graphics, where I was a chief scientist. The Mentor Graphics was acquired by Siemens. My background initially is computational physics, so large-scale simulations and large problems like field solvers, things like that. So I got to work on the early supercomputers.
Oh, wow.
And then when I went into industry, so I worked for Mentor Graphics, went up from an engineer to the chief scientist, did a short stint at Google, came back to Mentor, then joined Siemens. We're doing electronic design automation software. So again, large capacity, large throughput, massively parallel systems, solving very large computationally intensive problems. It's basically the tools for using the current generation of computers to design and build the next one.
That's awesome. And you've been going to CppCon since it started, right?
My first CppCon was 2014.
And then, yeah, I know you've presented at a bunch of them.
I presented at everyone I went to. I skipped the COVID one.
Yeah, I think a lot of people would have preferred to skip. Well, we had a great online program, but it's definitely. I'm looking forward to seeing you and everyone else, that's going to be on site. And so the class you're teaching this year is Performance and Efficiency in C++ for experts, future experts, and everyone else. So that's a post class, right? It's going to happen after the conference?
It's a post class, so the weekend after the conference.
And 2 days. I know from at least hearing your talks, I'd be excited to take your class, but why don't you tell us a bit about it?
So, first of all, the class, I've never taught the class in this class in public. I did teach it internally at Mentor Siemens. I gave a workshop at UCLA 2018 that is, you could say it's a very early version of this class. Also, I have a book on the art of writing efficient software, which covers most of the material I will be presenting. So you could view the class as a sort of interactive and guided exploration of some of the material in the book. I have some newer material that didn't make it into the book. I have for the class some fundamentals of high performance computing that I must cover, but I have prepared a lot more material than for 2-day class. So I'll poll my students, see where their interests and their programming needs are, and there will be some parts that I'll choose based on that. So I actually don't know the entire class I'm going to give yet.
That's really kind of cool though, because I can't remember how I came about it, but I thought when I saw your talk at C++ Now, when we were talking, I thought I saw some, I'll say additional slides and stuff that you were like, all of the things that you had to cut out. And my point to this is like the breadth of the knowledge that you have on this, to be in a class that, at least has that little bit of dynamicism, so that if I had something, that was in line with the efficiency, to be able to get the input from the class and direct it that way, That's exciting. Um, have you had good luck doing that with classes before when you were doing it internally?
Yes, so all the classes are very interactive. Uh, I have the planned outline, but based on the experience level and the interests of my audience, I can deviate, especially in the exercise part where I can add more or less complex exercises or focus on some of the things that I feel like they need to know.
Mm-hmm.
Now, the important part of this class is, and I think it's very important in general for teaching performance aspects, or well, probably not just performance aspects, but in programming, specifically performance, where a lot of the results are very context and objective specific.
Right.
So it's hard to actually teach knowledge in a useful way. It's not hard to teach knowledge. It's hard to make it useful over long term. So
Yeah, it's easy to show what a pattern is, but then to turn around and know where to apply that pattern, I think that's what.
that, but with performance, so I can tell you like the facts, and and some of them are very universal, and some of them are the happenstance of the current hardware and its interactions with the compilers and the language.
Mm-hmm.
So large part of the class, and that's where the interactive work, the exercises come in, is actually for this audience to figure out how did we get to the conclusions.
Okay.
So it's basically learning how to learn, the process for finding the answers, because when they get to their own work, they may find entirely different answers.
Understood.
So the things that I told them to do or not to do may turn out to be false. But the way you arrive to, okay, this is false, what should I do? The way you arrive to that answer, that is pretty universal.
I understand. So it gives them the tools to actually not just learn it from the example, but to take it back and implement the knowledge that they gained from doing that.
Yes, and as I said, some concepts are, they would be hard to violate. It would
Mm-hmm.
take some very unique system to change some of these. So those I teach as like more or less universal truth in performance, and others are, even though they may be true today widely, uh, I would always say, how we arrived to this conclusion.
Mm-hmm.
Uh, if you have that same problem, don't trust the conclusion,
Right.
trust the methodology.
Understood. And so definitely a hands-on class with a laptop,
Yes,
writing
so
code.
they would need a programming environment, profiling. I It would be easier on the students. I don't require it, but it would be easier if they had access to my book on the art of writing efficient programming, simply because they can go back and reread portions of what I explained at their own pace, during the breaks or after the class. Uh, as I said, a lot of what I'll be covering is explained in the book. So after sort of learning how we got there, maybe as a sort of summary of, okay, what did we get to, and now with a better understanding, reading this text would make it easier to follow the actual like process for optimizing or for profiling, for exploring performance.
And I could see that also just being nice to have as a reference even after the class is over to be able to go back to as well.
Yeah, so a lot of it does make for kind of a reference of techniques So that too. Now, one kind of general comment. So I did put it in the class description, but one general comment: I focus on performance as seen by high performance computing people. So if you were programming for like a cell phone, and performance for you is basically measure it in battery lifetime, the methods themselves would still be relevant. The conclusions would largely not be relevant for you because we will be measuring what you would consider a wrong metric. But the process for measuring the right metric would still be largely the same.
Yeah, so I might show my lack of knowledge here, but isn't it kind of, as I understand, it's like when we're measuring that performance, you always want to get the process done just as quick as you can, because it's either for getting the results or for you use less battery if you're more efficient and more performant anyways, right?
No, see, the high performance targets, the low power targets, and the third type is low latency targets. They actually have very different requirements. So, for example, if you look at the high performance computing, and that's one of the things I will in some way cover, you will discover that you can get the result faster by doing some unnecessary computations.
Okay.
The trick is you just don't know which ones are unnecessary until you get there. But basically, you will be doing more work than necessary. And the mantra there is, if you have idle silicon, use it for something that has at least a chance of being useful. Because
Oh,
at this
okay.
point, you don't care about power.
Right.
We're talking about like pure, maximum throughput.
Understood.
So you don't care about power. And let's say, you have a processor that can do like 7 instructions per cycle. If you're currently doing 4,
You're
you
wasting.
might, you're not losing anything by finding 3 more to do.
Yeah.
So if there is a chance that it might be useful, why not? But it will significantly increase the power consumption. So
Right.
this is something you never do in a low power environment.
That's an awesome description. Yeah, that makes me want to make sure I can get into your class even more if possible. So are you
And
giving
of
any
course, low
talk?
latency is a totally different game. I actually never worked in that space, so I know, only from general reading. It's a lot of it has to do with like concurrency, predictability, maintaining the correct priorities, like never delaying, the tasks that must happen quickly, and so on. So a lot of lock-free concurrent algorithms and data structures are relevant for this, just as they are for high performance, for high throughput work, but they're relevant for entirely different reason. And sometimes you end up with different data structures. The only thing I tell about it, so at the beginning of my class, I will show sort of the same program, just a condensed like version of, because the program doesn't do anything useful. It's just a small snippet of code, but basically optimized for the minimum power, the maximum predictability of the latency, and for maximum throughput, and it's different optimizations.
Okay, I gotcha.
And that's basically all I'm going to say about it, about the other two, and focus on the high throughput.
Understood. So are you doing any talks this year?
I'm not giving a talk at CppCon itself. I decided to invest more time in preparing for the class. And
Well, and
no.
then you're not busy doing slides all, you're not doing your slides all week trying to get to your talk, right? I mean, because that's the joke. Speakers are never done with their slides.
Well, I'm doing slides for the class.
I was trying to look at the positive.
But I basically, it's my first class at CppCon. I didn't want to divide my preparation between two, like a talk and a class?
Having only done, 2 talks and one of them being very, it was a half-hour talk, I can appreciate what you're saying because preparing for, even an hour talk is comparative to doing a class. I mean, I can understand the preparation difference, but either way, I think people will be in for a treat if they take your class.
I hope so, yeah. Kind of, at the last moment, I almost regretted not doing it because in my work I came across both some new performance-related things that I haven't taught anywhere, and I don't know if I'll teach them in the class. Again, it depends on what the what the interests of the audience are, but it has to do with large-scale hardware and also the C++20 concepts. And well, I guess I'll just have to wait until CPP Now and the next CppCon to submit a talk on those.
I I was just about to say the same thing, but then I figured that's what you would do anyways. So
Yeah,
Fedor, I really appreciate your time today, and I look forward to seeing you at the conference.
likewise.
Have a great afternoon.
Thank you. You took it.
Bye bye.